Okay, so there are various ways to draw world diagrams, right? I'm going to discuss one way to look at this problem that makes it really simple to analyze this problem. Is that what I've given to you is that this S prime frame of reference is the frame of reference that's moving along with your particle. So your particle is at rest in your S prime frame of reference, and S frame of reference, S prime frame is moving with a velocity v. So that means that if you think of the particle itself as S prime frame of reference, the particle would be moving with a velocity v in your S frame of reference. Now, before I draw the world diagram or I draw the world line for this particle in both frames of references, so your particle is then at any time t in your S frame of reference will be at some point x comma ct. At any time t, let's say its coordinate is x. So this event is represented by a point in your world diagram, right? Now, to find what does the world diagram or what does the world line looks like in S prime frame of reference, first, the idea is to draw S prime frame of reference or your world map in S prime frame of reference over and above this S frame. What does this mean? This means that I need to figure out where will be my x prime axis if I want to draw that x prime axis in this S frame of reference, and where will what will be my ct prime axis look like in S frame of reference. If you are able to draw your S prime coordinate system over and above your S coordinate system, drawing the world line or the world cone is not difficult. Okay, so suppose first I want to draw x prime axis of S prime frame in this world diagram. Now you need to think about what would x prime look like on this world diagram. To think about that, let's imagine that now since your particle is at rest in x prime frame of reference, let's look at a particular case where your particle is at some point x prime on your x prime in your S prime frame of reference, and it will continue to remain on x prime. Why? For all ct, so at time t equal to 0 or at some time later t prime also, it will continue to remain at x prime all the time. Why? Because it is at rest with respect to S prime frame of reference, right? So x prime axis could be seen as hence. So this is something which is very important. If you are able to think through this, then it's going to be easy for you to draw. So what would x prime axis be? X prime axis will be world line of this particle moving with velocity v in the frame of reference S. So suppose it's at some x prime in your S prime frame of reference. It continues to remain at x prime in your frame of reference as time progresses. Now this particle is moving with respect to S frame with a velocity v. So this x prime axis will be the world line of your particle in S prime frame of reference. So what would be x and ct corresponding to this? Now, according to Lorentz transformation, x and x prime and ct prime and ct are related through Lorentz transformations. Now this x prime axis corresponds to Ct prime equal to 0. If I substitute that here, I get a relationship between x and gamma beta x prime. Now, what would be the slope of the whirl line of the particle with respect to x-axis? The slope of the whirl line with respect to x-axis this should be the velocity of the particle. Sorry, yeah, this would be the, this would represent, not velocity, inverse of that, but this would represent the slope of this whirl line in S frame of reference, and this would be equal to, if you take the ratio here, equal to beta, and beta is less than 1. So tan of some angle theta, which is the slope with respect to x-axis of this whirl line, will be beta, will be less than 1. Now this is something you need to really understand. It is not, it doesn't come to you so straightforward. It's something that needs to be thought through.
Ma'am,
I want to represent this x prime line. This x prime line, just let me complete it, Vipin. This x prime line represents the whirl line of this particle, which is moving with velocity v in my S frame of reference. Why is this the whirl line? This is the whirl line because that's what I tried to tell you in the beginning, that the particle is at rest in your S frame of reference, S prime frame of reference, and let's say its initial coordinates are some x prime equal to x prime and Ct prime equal to 0. So x prime axis represents the whirl line, and this whirl line is represented in S frame by a straight line. Why a straight line? Because it's moving with a uniform velocity. And what is the slope of that straight line in x frame of reference is Ct by x. Vipin, ab bolo, what were you saying?
Ma'am, beta is V by C, right?
Beta is V by C, yes. Have I made a mistake here?
So slope would be 1 by beta, I guess.
No, see, it depends with respect to what you are representing, measuring the slope. So right now, I'm trying to measure angle with respect to my x-axis. So if I look at this x prime axis, tan of beta with respect to, so if this is my theta, I call this as theta.
Yes, ma'am.
Tan of this theta. So the way I have defined theta right now is this with respect to x-axis here of this whirl line.
Yes, ma'am. But when we draw the light cone, when we were studying this world diagram, so the light cone used to be like around the y-axis. Yes. So any velocity would lie inside the light cone, right?
Yeah, true. But that light cone is the light. So you have to now think about, I have not yet drawn the light cone.
Okay.
See, the light cone, in which frame of reference are you talking about? That has to be very clear. Right? So,
okay, yeah,
so the light cone will be represented by this. If I just extend the xct prime, wait, let me erase it and redraw it. What was the light cone? the light cone was in my this particular frame, S frame of reference. This was my light cone.
Yes, ma'am. So, like any particle in S frame of reference with velocity less than c would lie inside the light cone.
In this region.
Yes, ma'am.
Right?
So the particle, yes, ma'am. Like the particle given here moves with velocity v in S frame of reference, right?
No, but then you have to remember the way we are now looking at. So there is a relationship here that I have. Right? And this is a particular case where my particle at all times t is remaining at x prime and is moving with x, moving in x. So you have to, let me just complete the diagram. I'll redraw the light cone and I'll show you what you are saying is correct. But the light cone has to be drawn with respect to which frame of reference you are looking the motion at, right? So let's just first, right now, let's just remain with the what we are actually getting with the maths, right? Let's just keep the maths correct. So what I just drew here was, let's say, let me not draw a very big diagram because I'll have to otherwise keep erasing it. Is, let's say I have this as my coordinate system and I go by my Lorentz transformation. Let's for the time being just try to draw the coordinate system and not talk about really whether that's the true motion of the particle or not in that frame of reference, right? So I'm first just trying to draw the coordinate system. So imagine, just imagine, so if I want to draw x prime axis, now imagine this x prime axis being a world line. So what I'm trying to say is that if I want to draw x prime axis and ct prime axis with respect to x and ct, how do I visualize x prime on xct? Whether it's correct or not, we'll come to that later, right? So suppose I want to draw this x prime with respect to x and ct on my diagram, on this diagram. And x prime is represented by world line of a particle. Now, what kind of a world line would this be? This is a world line. So if I have this particle, which is moving with velocity v, with respect to my S frame of reference, and has some coordinate x prime at time t equal to 0. X prime axis with respect to x prime and ct prime coordinate system, x prime axis is represented by ct equal to 0 always, ct prime equal to 0 always, right? And x prime is represented as, let's say, the world line of this particle. Now, if x prime represents world line of this particle, what would that mean in terms of x and ct? That would mean in terms of x and ct is that x is some gamma times x prime and ct is some gamma beta times x prime. And what would be the angle that this x prime would make with respect to, I will find out the angle with respect to both x prime and ct prime, x and ct. So let's say first I'm trying to measure the angle that this x prime is going to make with respect to the x-axis, and I call that angle theta. Now, what would be that angle theta? That angle theta, if this is a world line, x prime, then this angle theta would be the ratio of its the ratio of its ct and its x. So I'm now defining this theta with respect to x. I'm actually defining this theta with respect to x. And what does this tan theta comes out to be for this particular x prime from here? It turns out to be this beta. This beta is less than 1. So that means tan theta is less than 1. So you will have something like this, right? Why? Because tan theta equal to 1 is my b equal to c axis. So this x prime, if it was to represent Bird line, so now here it comes, what you are really asking is that suppose this x prime would actually represent the world line of this particle, then it's going to lie in this particular region of my world cone, right? Now, if I was to represent CT prime axis on this coordinate system, how can I visualize CT prime axis? Now, CT prime axis is actually x prime equal to 0. Now, since the particle is stationary in S prime frame of reference, it's going to represent, CT prime is going to represent world line of a particle, which is at time t equal to 0 is at x prime equal to 0 and will continue to remain at x prime equal to 0 for all times. So CT prime is going to now represent the world line of a particle, which according to Lorentz transformations is going to give me a relation between x and CT by putting x prime equal to 0 in my Lorentz transformation. Now, what is the slope of this world line in my original XCT diagram? I can measure its slope with respect to CT. If I measure its slope with respect to CT, then CT by gamma x comes out to be, in this case, 1 by beta is less than, is greater, now 1 by beta is greater than 1. So tan phi, that is angle with respect to x-axis, is such that it is greater than 1. So what does this mean? That if I want to draw this with respect to x, it's going to lie in this part of the world diagram. See, you have to remember whether it is true motion or not, I don't know. I'm not commenting on that. I'm just trying to draw world lines, possible world lines, whether they are true world lines, whether they are world lines which are really possible or not, I don't know. I just don't know. But suppose the world line was represented by CT prime. Then CT prime would be a world line which will have an angle tan phi with respect to x-axis in such a way that it would be greater than 1. So that means CT prime would lie in this part of the world cone of my original coordinate system xy. So this should be my phi. I can also find this angle that it will make with CT. What would that angle be? That angle would be actually x by CT. That comes out to be again beta, which is less than 1. So this angle will be same as this angle. So now you see I have actually drawn what would, suppose x prime was to represent world line of my particle in XCT coordinate system, and suppose CT prime was to represent the world line of a particle in XCT system, then these two world lines will look like this. And that's exactly what I want to achieve, is to see how does my x prime CT prime coordinate system looks like if I try to draw it on X and CT world map. I am not saying that this will really represent a true motion or this will really represent a true motion. Right? I'm assuming that if it was to represent a world line, how would they look like? Right? So now it is interesting to see that how would your, if you want to redraw, if you want to draw this diagram, a big diagram, because this diagram is what is important. So if you have your X and CT coordinate system, and this is the world cone, light cone, B equal to C in this coordinate system, then X prime and CT prime coordinate system. I'll use a different color. I think that's better. I'll use a different color. So this is what my X prime and CT prime is going to look like. So you can see that this area, so if I was to look at the allowed light cone area, right, the allowed light cone area, and hence I need to think about what we used to call as, so this was in this light cone with respect to this X prime CT prime would represent my absolute past and absolute future in my original coordinate system. You must see that original past and now the absolute past and absolute future, the size of that part looks different, right? Now, if I was to now go back and represent, so if I had a world point XCT, now you have to think that this is truly a world point, an event in my frame of reference. Here, some XCT. Then what are its coordinates? Its coordinates are given by drawing lines parallel to X. So this was a line which would mean for a constant X, and this would be a line which would imply for a constant C, constant CT. But now the same event will have different coordinates in my new coordinate system. And how will I draw that? To draw its corresponding values, I will have to now draw lines which are parallel to. So its coordinates will look like X prime 0, CT prime 0. Right? So any arbitrary point. Now, what is its world line? Well, now you can think about what would be the value of V, whether a value of V is allowed or not, is that this point will lie within the light cone here or whatever, and hence figure out where it would lie within the light cone in X prime CT prime. The idea that I used in the beginning was just to draw my X prime axis and CT prime axis. That one has to be, that's the whole idea, and not think about whether that truly represents a world line or not. I know this is a tricky question. That's why I wanted to do this first, because I want you to now think about, now since the time is for the meeting has to be restarted. I'll restart the meeting. In the meantime, you just think about what I just did on the board.